Okay, 8th graders, on Monday we talked about slope, and you guys, we did the first couple of pages in our linear equations packet. So today we are going to go to the 3rd page, and we are going to talk about linear equations. Okay, a linear equation is an equation whose graph produces a line. Okay, so if you look at all of these 3 graphs, which one is linear? And this line has to be straight. That is the other thing. So the only graph that produces a straight line is C. Okay, so there are different ways you can represent a linear function. The first one is graphs. Now we're going to kind of move on, and we're going to be given an equation. An equation is an example of a linear equation. To graph it, let's complete the table below by finding the y values that will satisfy the equation x plus y equals 3. Then we can plot them as ordered pairs. So I already picked out some numbers for you, and so what you're going to do is we're just going to plug them into this equation really quick. Now, to be honest, this equation isn't very handy to solve for y's, so what I'm going to do is I'm going to get y by itself, and I get y equals 3 minus x. So if I have 3 minus negative 1, what do I get? Well, I get 4. 3 minus 0 is 3. 3 minus 1 is 2. 3 minus 2 is 1. So now I'm going to graph these points. So negative 1, positive 4, 0, 3, 1, 2, and 2, 1. You can see what happens with these points. Just going to grab my Post-its here and connect my points. Okay, so it created a straight line. So let's mark more points and draw a line through them. So we kind of did that. Circle the ordered pairs that below that are on the line. So let's check these pairs. My first one, negative 2 and positive 5. 1, 2, 3, 4, 5. So this one's on there. Positive 4, 2. Positive 4, 2. Is that one on there? Nope. 3, 0. Positive 3, 0. Yep, it's right here. 12, negative 9. Well, first off, can we even do 12 on our graph? No, but how else could we check it? Could we put it into the equation and make sure it's true? So 12 plus negative 9 equals, does it equal 3? Yes, 12 plus negative 9 does equal 3. So that one's kind of tricky to check using the graph. So same thing with these larger numbers. They're difficult to check if we don't have a graph that's large enough, and that's kind of what we're going to look at today, is how can we use the equation to check. So remember, this is your x and this is your y. So negative 32 plus 40, does that equal 3? No, gives you 8. So not this one. What about 2.18 plus 0.82? 18 and 82 gives you a full whole. So does 3 equal 3? Yes. Negative 7.2 and 9.6, they're technically, we're subtracting those. So if I like to picture it like this. And I get 2.4, so that one's a no. But what about if this is your x and this is your y? You have 1.5 plus 1.5. Does that equal 3? It does. So some of them you're able to check using your graph, and other ones you have to see if it makes the equation true. And that was that x plus y equals 3 equation. So it's not easy to tell from the graph whether or not some of the ordered pairs above are on the line, but it helps to remember something very important. The graph of an equation in 2 variables, so an x and a y, they could use a C and a D, M and an N, is the set of all its solutions. So if it makes the equation true, that means it's going to be on the line, even if that line is somewhere we can't see it. So it says, let's decide whether the following points are on this line. So what we're going to do is we're going to take these points, these coordinates, these X and Y's, and what are we going to do with them? Can you guys guess? We are going to put them into the equation, and we're going to see if they are true. So I have 2 times X, which is 4, equals my Y, which is 15, minus 7. So what is 2 times 4? That's 8. What's 15 minus 7? That's also 8. So if it's true, then yes, this is a solution. So let's check the next one. So I'm going to do 2 times -1 equals, and then it's going to be a 6 because my Y is 6, minus 7. Well, 2 times -1 is -1, or -2, sorry. 6 minus 7 is -1. Is this true? No, this is false. So no, this ordered pair is not a solution of that equation. Let's try one more here. We have 2 times -8.6 equals, my Y is -10.2 minus 7. Too many pens here. So if I double this negative, it's going to stay negative. And if I double 6, I get a 12. And then this is 16, 17, 18. Oh, sorry, I got to carry the 1. So it gives me 17.2. Okay, this one, you're at -10.2 and you decrease 7 more, it also gives you -17.2. This is true, so yes, this is a solution. And that is how you check. Okay, so if you have any questions from that, just kind of write them down. You can always ask me later. We're going to go to the next page here. So sometimes you can recognize whether an equation is going to be linear, so whether it's going to be a straight line, just by looking at the equation. Some of them are more complicated than others, but I'm going to show you a couple things that you can look out for. Okay, so if you look here, some of these all look different, but there are some things that are telltale signs that it's going to be linear. And actually, I think it's easier to pick all the things that make it not linear. So for example, one thing we can't have is we can't have any exponents on our variables, okay? Another thing, our variables cannot be multiplied together, okay? The next thing, we can't divide by our variables. Our variables cannot be underneath a radical symbol, and they can't be in the exponent. The other one that we sometimes forget is that it cannot be in an absolute value symbol. So I'm just going to make a little list here. Cannot. I'm going to say X and Y cannot have an exponent. Multiply together. Cannot divide by X or Y. Cannot be in an absolute value or under radical. and cannot be an exponent. I just sometimes making that list might be helpful for you guys so that you don't just forget what I've highlighted here. Okay, so in conclusion, linear variables or linear equations must have variables, so there has to be an x and a y, and the variables may only have coefficients. The coefficient is the number in front of the variable. Now this is kind of tricky because if you look here, our x and y's don't have something in front of them, but there's always an understood 1. Okay, and I know this is kind of a lot to take in, but let's just look for those things that it can't be. So for example, I know it can't have an exponent. Okay, I know that x and y can't be multiplied together. I know that the variable can't be in the denominator, can't be divided by that. And that's kind of the telltale signs of things that I can't have. Okay, now you guys don't know enough about this yet, but I can assure you that the other equations are linear. And you will learn more about these as we go. Okay, so we can also recognize that linear relationships by looking at tables. The table below shows 3 solutions to a linear equation. Prove this relationship is linear by finding the rate of change or slope between its ordered pairs. Okay, so in order to find the slope, we just learned that on Monday. So we use our equation, the y2 minus y1 over x2 minus x1. And these 3 problems are finding the slope between -5 and 13 and 1 and 1, -5 and 13 and 12 and -21, and then 1 and 1 and 12 and 21. So it's finding the slope between all those numbers and to see if it's the same. So what I'm going to do is I'm going to put these numbers in, x1, y1, x2, y2, and I'm going to solve. 1 minus 13 over 1 minus -5. Remember, when you subtract a negative, it turns to be addition. 1 minus 13 is -12. 1 plus 5 is 6. So this changes to -2. Okay, let's do our next one. x1, y1, x2, y2, -21 minus 13 over 12 minus -5. Add the opposite, add the opposite. -21 plus a -13 gives us a -34. 12 plus 5 is 17. If I divide this, I get a -2. So that means these two are the same. So let's just check our last one now. x1, y1, x2, y2. -21 minus 1, 12 minus 1. -21 minus 1 is -22. 12 minus 1 is 11. When you divide -22 by 11, you get -2. So being that they are all the same slope, yes, this is linear because the slope stayed the same. If you think back to your graphs in the beginning here, these slopes were changing. It was increasing, then it decreased. But this slope stayed constant the entire time. And that's what we just found with finding the slope mathematically, was that it stayed the same the whole entire time. That means that it stayed a straight line. So it says that when one value grows by equal differences, it is easy to recognize relationships. Find the linear relationship. So for example here, these all go up by 1, 2, 3, 4. So these all increase by 1s. Well, let's check the other side. So this one increased by from 7 to 10, I get 3. From 10 to 12, I get 2. And from 12 to 16, I get 4. Was that a constant rate? No, so then it's not linear. These all went up by 1s. Let's check here. From -1 to +4, that was 5. From 4 to 9, that's also 5. From 9 to 14, that's also 5. So this is constant, so yes. And maybe I'll just jot here. Okay, let's check another one. This one went from 2 to 4 to 6 to 8, so this was constant here. Let's check this one. From 3 to 4, it was 1. From 4 to 6, it's 2. From 6 to 9, that's 3. So yes, it's a pattern, but no, it's not linear because it's not going to form a straight line. Okay, the next one. If I check this side, I'm going up by 3s, which is consistent, but let's check this one. So I went down by 3, 17 to 14, down by another 3, 14 to 11, down by 3. So you can increase or decrease, it doesn't matter. They're both consistent. So yes, they do not have to be the same number as long as they're both going up or down by the same thing. Okay, last one. These went up by 1. What happened here? This one went up by 1, then up by 2, then up by 4. Is this consistent? Is it constant? No, so then it's not linear. Okay, so the last type are kind of like actual situational problems. And so we want to know if it's consistent, if it stays constant. So Jack makes $14 an hour. Does the amount per hour that he makes differ at all? No, he's always going to get paid $14 an hour. So the more he works, the more he gets paid. So this is linear. Each year, I get $1,500 raise in salary. So what's going to happen to her salary? It's going to go up by exactly $1,500 a year. That's a constant amount. So yes. The baby grew fast at first and then slowly. This is kind of showing a variable thing. So no, that would not represent a straight line. It might, like if we were graphing this, you guys can kind of visualize these. It might show that the baby grew quickly and then kind of leveled off, something like that. So that wouldn't be a straight line. The number of cells doubled every hour. And this is going to be a no because that number is all of a sudden going to get way bigger. This is called an exponential function. Each year I get a 5% raise in salary. So yes, it raises the same percent every year. And this one's kind of tricky, but if I made $5,000 one year and I get 5% of that, then I make $10,000 another year and I get 5% of that, is that the same number? Is that the same amount of raise? And the answer is no. My company is losing $1,000 every month. Is the change equal every time? Yes. So if it's a constant change, it means linear. That's something to consider. Okay, so for your guys' homework, you're going to have this linear equations homework. And it's just these 2 pages, the front and the back. And you can just send me any types of questions that you guys might have. Good luck.